Hello friends. Now we'll start electric potential part 11b. You know that very well. Last lecture, that means in part A, we discussed very important formula. The formula for electrical potential energy of, you know that very well, dipole. Electrical potential energy of dipole. So electrical potential energy of dipole, and dipole which is placed in uniform electric field, and you know that very well, we derived this formula most time be minus P dot E. So very IMP point. We also derived one most IMP formula, the work done required, or I can say that potential energy whenever you would like to deflect, or I can say that rotate the dipole or displacing the dipole from one angular position to other angular position. That means from theta not angular position, this is your initial angular position, to theta 1, that means final angular position, and it is, you know that, minus PE cos theta naught minus cos theta 1. This is the most IMP formula. You know that very well. It is Dhoom formula. So today we would like to think about few numericals from this NCERT textbook based on electrical potential energy. All we can say that numericals are very IMP, and these two numericals, first and second, we discuss, very important for competitive point of view also. So just concentration required. In last lecture we derived this formula by using two different methods. Number one, on the basis of, we can say that work done, small work done, then integration, that means by using external torque multiplied by displacement. While in the second method we derived formula of U is equal to minus P dot E by consideration of electrical potential energy in the presence of external electric field, case number 2, you know that. So this is the most IMP concept, you know that. Now we would like to think about application of this all concept. So just concentration required, you know that very well. These all conceptual points are very IMP for us. So just concentrate here and try to understand. First of all, suppose there is 1 mole substance is given here. So 1 mole substance with you, ready? And in this 1 mole substance, there are lots of molecules. Suppose this one is the 1 mole substance, and particularly for one molecule, the dipole moment is given. It is P, you can see, suppose. Value already given, don't worry, we discuss. So the dipole moment of one molecule is given. This value is already with you. So now electric field is applied to the substance. You can see here lots of dipole, and these dipoles are called atomic dipoles, like this one. You can see whenever electric field is applied, then these atomic dipoles get deflected from equilibrium position, or from, you can see that, 0 degree position to 60 degree position, like this one, 0 degree to 60. So all atomic dipoles get deflected from 0 degree to 60 degree. Then what is the, we can say that, change in potential energy, or we have to find the loss of potential energy, that means the heat energy produced. तो पूरी कहानी देखी जाए तो बहुत इजी. हियर अप्लाइड इलेक्ट्रिक फील्ड इज ऑलरेडी गिवन, डोंट वरी. इलेक्ट्रिक फील्ड E already given, 10 raised to 6 volt per meter, don't worry. And next point, dipole moment already given, we'll check it. So next point, what's your target? The target to find first of all change in potential energy. So change in potential energy, because whatever the potential energy is changed whenever this dipole get deflected from 0 to 60 degree, whatever the potential energy, we can say the change is, this change in potential energy is converted in the form of heat energy. So change in potential energy, you know that U is equal to, it is PE cos theta 0 minus cos theta 1. You know that very well. This is the formula, and theta 0 is the initial position and theta 1 you know the final position. So what is the initial position here? Here theta 1 already 0 degree, you know that, and theta 1 because of application of electric field, here dipole is oriented from 0 degree to 60 degree, or I can say the deflected or rotated from 0 degree to 60 degree. So theta 1 is the final position, it is 60 degree. So P given, but we have to think about 1 mole substance. This is the most timing point. Many students sometimes read the data and we can say they apply logic very fast. So please thamba, dhire chalo, because of one word, 1 mole substance. Because here whatever the dipole moment is given, it is only for one molecule. While you have to calculate this entire, we can say this procedure for 1 mole substance. So you know that very well, in 1 mole substance how many number of molecules are present. It is equal to Avogadro number. So first of all, we have to find total electric dipole moment, but for 1 mole substance. And you know that it is, what is the, we can say the dipole moment of one molecule P. So total electric dipole moment, it is 6.023 into 10 raised to 23 multiplied by dipole moment here given 10 raised to minus 26 coulomb meter. Okay, 10 raised to minus 26 coulomb meter. So electric dipole moment of one molecule is given. So if you simplify, then it is 6 into, here 6 given, don't worry, 6 into 10 raised to minus 3. Okay, so we will refer the data again such that there is no mistake. So 10 raised to minus 29, not 26, you can see that minus 29, sorry for that, but so minus 29, and here particularly for this numerical, the number of molecules here not in the form of 6.023 but 6, don't worry. So minus 23 minus 23 minus 29, so obviously minus 6 coulomb meter. So total electric dipole moment with you. So now whatever the we can say the changing potential energy, it is simply the heat energy. Directly I can write heat energy is equal to PE. PE, once again I will write formula cos theta naught minus cos theta 1. You know that P is the total electric dipole moment. Now for 1 mole substance, it is 6 into 10 raised to minus 6. Electric field already here given 10 raised to, you know that very well, 6 volt per meter. So 10 raised to 6. Initial angular position 0 degree as per discussion, and finally 60 degree. So if you simplify, minus 6 plus 6 cancel 6. Okay, and what is cos 0? 1 minus 1 half. So 1 minus 1 half, that means 1 half. So obviously 3 joule. So 3 joule you can see there, and whatever the change in potential energy, it is 3 joule. So this 3 joule is obtained in the form of heat energy. So this is the most time numerical we discuss. You can see very IMP for MCQ point of view. Basic process very easy, mathematically very easy, but whatever the wordings of this we can say that, or I can say that words are used in this type of data. These wordings are very important for this numerical or MCQ. This is your illustration number 2.6, very important for 2 marks numerical, and I can say that MCQ point of view. Once again, what happened here? Here electric field is applied because of this 10 raised to 6 volt per meter electric field. What happened? Here atomic dipoles of 1 mole substance get deflected from 0 degree to 60 degree, and that's why whatever the change in potential energy because of this orientation, or I can say the displacing, it is converted in the form of heat energy. So we would like to calculate this heat energy. This is the methodology. Very easy, but you can see this formula again. I can say very IMP formula. E cos theta, cos theta 0 minus cos theta initial and final position. Now friends, we'll discuss the next one. Next one is very important, again potential energy related. So अपन लोग आज पोटेंशियल एनर्जी का जो डिस्कशन करने जा रहे हैं, ये अब लास्ट है, उसके बाद प्रैक्टिस देखेंगे। ये एनसीईआरटी रिलेटेड जो मैं न्यूमेरिकल कहने जा रहा हूँ वो पोटेंशियल एनर्जी रिलेटेड लास्ट न्यूमेरिकल, बट वेरी आईएमपी फॉर 4 मार्क्स, सो बी अलर्ट। इसका प्रॉब्लम यही है कि इसके जो वर्डिंग्स है वापस वो भी काफ़ी लोगों को समझ में नहीं आते हैं। सो रट्टू पोपट बी अलर्ट जो मैं न्यूमेरिकल डिस्कस करने जा रहा हूँ। सो ये दोनों न्यूमेरिकल्स वेरी आईएमपी, इलस्ट्रेशन नंबर 2.6 एंड नाउ वी डिस्कस वन मोर। So what is this? We'll discuss, but check it. So concentration required, very IMP for 4 marks. Okay. So we'll think about data. Okay. So just concentration required. First of all, we have to calculate. First of all, here two particles given, proton and electron, and they both are separated by distance 0.53 angstrom. So you can see this is your proton and this is your electron. They both are separated by distance 0.53 angstrom. Ready? So there are three parts. We have to think about three parts A, B, C. First of all, part A. Keep in mind whatever the numerical we are discussing, it is 2.18. So you can easily take reference of, you can see the textbook 2.18, very IMP for 4 marks. Don't forget. So once again, two particles given, proton and electron, they both are separated by distance 0.53 angstrom. The first question start. First part A. Turn by turn we will discuss. First of all, start with A. Concentration required. Estimate the potential energy of the system in electron volt, but taking the zero of the potential energy at infinite separation of the electron from proton. A IMP word, taking the zero potential energy for separation infinite or zero of potential energy at infinite separation. यानी कि सबसे पहले तो अपन लोग जानते हैं बेसिक, मैं थोड़ा बेस बना देता हूँ इस न्यूमेरिकल के फर्स्ट 5 मिनट्स टाइम पे. You know that very well, there is a system of two particles, proton and electron, and you know that to form a system, to assemble a system, we have to do work. We have to move these proton and electrons from infinite to given point. यानी कि पहले प्रोटॉन को लाएंगे, उसका वर्क डन जीरो होगा क्योंकि इलेक्ट्रिक फील्ड नहीं है. फिर इलेक्ट्रॉन को लाएंगे, उसके लिए हमें वर्क डन करना पड़ेगा. वो हम सब डिस्कस कर चुके हैं. तीन केसेस इलेक्ट्रिक पोटेंशियल एनर्जी के याद रखने के, तीनों तीन. नंबर 1, electrical potential energy in absence of electric field, then second case in presence of electric field, and third case electric potential energy of dipole. अपन लोग फर्स्ट केस पे डिस्कशन कर रहे हैं absence of electric field because they do not mention about electric field. Okay friends, so proton and electron are already at infinite distance. You know that very well. Suppose proton is situated here and it infinite, electron at infinite. If they both are at infinite distance, then what's the potential energy? Zero. At infinite distance, potential energy zero. तो अब अपन लोग ये दोनों पार्टिकल्स को पोटेंशियल एनर्जी फाइंड करने के लिए इनफाइनाइट डिस्टेंस से कहाँ पे ले आते हैं इधर, और हमने सिस्टम बनाया. हमारा जो क्वेश्चन है वो ये पोटेंशियल एनर्जी ऑफ सिस्टम एंड पोटेंशियल एनर्जी ऑफ सिस्टम बट एट 0.53 एंगस्ट्रॉम सेपरेशन. ये सेपरेशन पे हमने जिसे कह सकते हैं पोटेंशियल एनर्जी फाइंड करनी. सो कंसंट्रेशन रिक्वायर्ड, this is the most timely point. You know the potential energy of the system, that means simply the work done. And one most timely formula already I given. Work done is equal to final potential energy minus initial potential energy. याद करो, पहले दोनों पार्टिकल्स होंगे कहाँ पे, इनफाइनाइट. और यहाँ पे बोला इनफाइनाइट पे होने का रीजन इसलिए क्योंकि स्टेटमेंट अच्छी तरह देखो. पार्ट ए, we would like to calculate potential energy of the system of these two particles at 0.53 angstrom separation, but what is the conditions? Get the zero of potential energy at infinite separation. यानी कि infinite, पहले दोनों पार्टिकल इनफाइनाइट पे होंगे तब उसकी एनर्जी जीरो, तब जीरो लेनी है. फिर दोनों को अपन लोग इधर ले आते हैं तब कितनी एनर्जी होंगी. तो वर्क डन का ये फॉर्मूला अप्लाई करें. ये मोस्ट टाइम की फॉर्मूला यूएफ. यूएफ का मतलब फाइनल. फाइनल अपन लोग जानते हैं इधर आ गए. इनिशियली कहाँ पे थे? Obviously at infinite. So first of all, work done is equal to, or potential energy of system at 0.53 angstrom separation is equal to work done. Work done is equal to potential energy at 0.53 angstrom minus potential energy at, I can write here, infinite separation. Ready? So potential energy of system is equal to work done. Potential energy of system, that means proton electron. Potential energy at 0.53 angstrom minus potential energy at infinite. So start. What is the potential energy at 0.53 angstrom? So we have idea about formula of potential energy, Q1 Q2 upon R. And what is the potential energy at infinite? It is already zero because they mention zero potential energy at infinite separation. So work done, that means potential energy of system is equal to W is equal to K already 9 into 10 raised to 9. Charge Q1 is the charge of proton, it is 1.6 into 10 raised to minus 19. Then charge of electron, obviously it is minus 1.6 into 10 raised to minus 19 upon R is the separation, it is 0.53, but angstrom 10 raised to minus 10. So what is the answer? It is minus 27.16. Sorry, this is, you can see that in the form of joule, because they asked the question in the form of electron volt. So we have to divide by 1.6 into 10 raised to minus 19. So joule is converted in the form of electron volt. So very IMP point. This is the most important point. This is your formula. But why we have divided by 1.6 into 10 raised to minus 19 to convert joule or energy from joule to electron volt. So your answer here minus 27.16 electron volt, and this minus sign because of this charge of electron. You can see that the first part we have discussed. What is the answer of it? Minus 27.16 electron volt. This is the potential energy of the system if zero of potential energy is considered at infinite separation. Okay, now I move towards the next part, second part, B part. So just read the data, particularly for B. What is the minimum work required to free the electron? And given that its kinetic energy in the orbit is half the magnitude of potential energy obtained in part A. अब क्या कहना चाहते हैं जब डिस्कस करते हैं? फर्स्ट पार्ट we discuss. Don't forget, this is very useful for the second part also. So what is the potential energy of system whenever they both are separated at 0.53 angstrom distance? But zero potential energy, it is called reference energy. Already you know that at infinite separation, जब दोनों चार्जेस को infinite separation पे थे तब उसके बीच की एनर्जी जीरो थी, तो 53 एंगस्ट्रॉम डिस्टेंस पे लाया जाए तो एनर्जी कितनी होगी हमने फाइंड किया. सेकंड केस, ये फॉर्मूला यहाँ पे रहेगा. सेकंड केस, दैट मींस पार्ट बी. What is the answer of part A? It is minus 27.16 इलेक्ट्रॉन वोल्ट. पार्ट बी देखो, अब ये प्रोटॉन और इलेक्ट्रॉन एक दूसरे के जिसे कह सकते हैं बाउंड स्टेट में है, और अपने को इस इलेक्ट्रॉन को फ्री करना है. प्रोटॉन पॉजिटिवली चार्ज, इलेक्ट्रॉन नेगेटिवली चार्ज. ऑलरेडी वी discussed this point, attractive nature, and that's why they both are in bound state of each other. But now we would like to make this electron free from the bound state of the proton. यानी इसको अपन लोग फ्री करना चाहे तो हमने इसका सिस्टम आपको ऑलरेडी बताया है. कोई भी इलेक्ट्रॉन या पार्टिकल को बाउंड स्टेट में से फ्री करना हो, to make the given particle free from the bound state, first of all always find total energy of that particle. In the fixed search, याद करो टोटल बाइंडिंग एनर्जी टोटल एनर्जी. और टोटल एनर्जी अगर बाउंड स्टेट में बंधा होगा तो नेगेटिव जाएगा, और अपन लोग जानते हैं जितनी टोटल एनर्जी नेगेटिव आए उतनी उससे ज्यादा एनर्जी पॉजिटिव फॉर्म में देनी पड़े. सो हियर दे आस्क द क्वेश्चन अबाउट वर्क डन यानी एनर्जी. सो फर्स्ट ऑफ ऑल वी हैव टू कैलकुलेट टोटल एनर्जी ऑफ दिस इलेक्ट्रॉन. थीम पता चला क्यों? हमारा बेसिक क्वेश्चन इस इलेक्ट्रॉन को फ्री करना हो तो कितनी एनर्जी या वर्क करना पड़े. तो वर्क करने का पूछे मतलब एनर्जी, तो हमें कितनी एनर्जी देनी पड़े वो फाइंड करना हो, तो सबसे पहले टोटल एनर्जी फाइंड करने की. सो टोटल एनर्जी ऑफ इलेक्ट्रॉन, इट इज ऑब्वियसली काइनेटिक एनर्जी प्लस पोटेंशियल एनर्जी. यू नो दैट पोटेंशियल एनर्जी already for this separation is given, that means we have calculated, don't worry. Now we have to find kinetic energy. So here kinetic energy of electron is half of magnitude of potential energy. It is already given in your data. So kinetic energy is equal to half of potential energy. What is the formula or magnitude of potential energy? 27.16. So if you simplify, then it is 13.58 electron volt. You can see 13.58. You can also think about calciflu. So 13.58 you can see, but here positive because magnitude. So now kinetic energy with you. So total energy of electron is equal to kinetic energy, it is 13.58 minus potential energy already with us 27.16. So total energy of electron is equal to minus 13.58 electron volt. You can see minus sign. हमने पहले ही बताया कि बाउंड स्टेट मतलब समझ जाओ, it is always in the form of negative. So here minus sign indicating that this electron already in bound state of proton. Now what amount of energy we have to supply? Very easy, you know that. So to make electron free, what's the condition? The total energy should be greater than equal to 0. So अपन लोग लिख सकते हैं therefore work done or external energy is required to make electron free is total energy should be greater than equal to 0. So what is the total energy? 13.58 is, we can say that greater than equal to 13.58. Okay, greater than 0 मतलब 13.58 है, उसका आंसर है वो पॉजिटिव या उससे ज्यादा होना चाहिए मोस्ट टाइम भी। इतनी एनर्जी प्लस वो तो पता चल जाए इधर से इतना प्लस के फॉर्म में। सो दिस अमाउंट ऑफ एनर्जी वी हैव टू सप्लाई और मोर देन दिस अमाउंट, then this electron can become free from the bound state of the proton. तो ये अच्छा क्वेश्चन था, वापस देखते हैं, वापस क्वेश्चन को एनालाइज करें। Whenever this proton and electron are separated at distance 0.53 angstrom, then what's the potential energy of the system? It is minus 27.16 electron volt. Now we would like to free to make this electron free. What's the work done required? That's your target. So we would like to calculate work done required to make the electron free. हम लोग जानते हैं इलेक्ट्रॉन को फ्री करना हो, यानी कि इलेक्ट्रॉन बाउंड स्टेट में हो, उसको फ्री करना हो तो अपन लोग को ऑलवेज एक ज गुरु मंत्र याद रखना है, उसका टोटल एनर्जी। सो फर्स्ट ऑफ ऑल फाइंड आउट टोटल एनर्जी ऑफ दिस इलेक्ट्रॉन, इट इज Ke plus P. Ke already given in the form of condition half of P. P already we have found, it is magnitude. So Ke and P with you, so you can easily find total energy. Total energy already here minus or negative. This negative sign indicating electron already bound state. And you know that what's the condition to make charge particle free from bound state? Its total energy should be greater than equal to 0. So work done or extra energy is required or supplied to make electron free is greater than equal to 13.58 electron volt. इससे ज़्यादा वर्क करो तो इलेक्ट्रॉन, इससे ज़्यादा एनर्जी दो तो इलेक्ट्रॉन फ्री हो जाए। So this is the second case we have discussed. Now we discuss the last case of this numerical number 2.18. What are the answers of to A and B? यानी A और B जो डिस्कस किया वो वापस करना है, but for different condition. If the zero potential energy or zero potential energy is taken at 1.06 angstrom separation. Check the number A. If zero potential energy is considered or zero potential energy at infinite separation, हमने जो कहानी डिस्कस की थी ये infinite separation, यानी कि दोनों चार्ज पार्टिकल की जीरो एनर्जी इनफाइनाइट डिस्टेंस पे हमने कंसीडर की थी। अब लोग ये ऐसा कह रहे हैं कि अगर ये दोनों पार्टिकल्स एक दूसरे से 1.06 एंगस्ट्रॉम की दूरी पे हो तब उसकी एनर्जी जीरो कंसीडर की जाए। सो व्हाट इज द पोटेंशियल एनर्जी एट वी कैन से दैट गिवन सेपरेशन, यानी कि 1.06 एंगस्ट्रॉम है वो हमारा जीरो पोटेंशियल एनर्जी रेफरेंस बनेगा। तो पहले वाला फार्मूला वापस डिस्कस करने जा रहे हैं। सो नाउ पार्ट सी, कंसंट्रेशन रिक्वायर्ड, पार्ट बी वेरी हैवी नो डाउट। Now part C very easy because it is very similar to part A. So what's the C? Part C, potential energy. First of all, we can say that check the data once again, क्योंकि इसमें एक पॉइंट में वापस बता दो what are the answers to A and B. That means we have to calculate only not only energy but also work done. Above, if the zero potential energy is taken at we can say that 1.06 angstrom separation. So we can say that potential energy of system, if zero potential energy at 1.06 angstrom separation, ये अपना हेडिंग। So we know that potential energy of system is equal to work done is equal to UF minus UI। पहले दोनों 1.06 एंगस्ट्रॉम थे, फिर वहां से अपन लोग कहाँ पे ले आते हैं 0.53। सो पोटेंशियल एनर्जी एट 0.53 एंगस्ट्रॉम, दिस इज योर UF माइनस UI। इनिशियली कहाँ पे थे? सो पोटेंशियल एनर्जी एट 1.06 एंगस्ट्रॉम मोस्ट टाइम पे। रेडी? तो अपन लोग अब पोटेंशियल एनर्जी एट 0.53 एंगस्ट्रॉम ऑलरेडी with us minus 20.16 electron volt. So we have to calculate potential energy at 1.06 angstrom. So now potential energy at 1.06 angstrom separation, it is K Q1 Q2 by 1.06 angstrom. मैं डायरेक्ट लिखता हूँ K 9 into 10 raised to 9, Q1 1.6 into 10 raised to minus 19, Q2 also but minus 1.6 10 raised to minus 19 because of electron, 1.06 into 10 raised to minus 10 because angstrom to meter point of view. But don't forget 1.6, it is divided by 1.6 into 10 raised to minus 19 for the conversion of joule to, we can say that, electron volt. ये बहुत ही चिकना केस. इस न्यूमेरिकल्स में लोगों के मार्क्स, खास करके जिसका दिमाग है उसका, रट्टू पोपट को कोई प्रॉब्लम नहीं क्योंकि उसको पता ही है ये सब रट्टे मारा है तो छापी देना है. So no problem. So if you simplify, then answer B, we can say that 13.58 electron volt. So this is the energy but at 1.06 angstrom separation. So now final answer will start. Potential energy of system is equal to, what is the potential energy at 0.53 angstrom? It is already we have found minus 27.16 electron volt. Ready? And here answer you can see that in the form of minus. There is a mistake because of this electron negative sign. So minus plus 13.58 electron volt. So potential energy of system U is equal to minus 13.58 electron volt. तो इतना जिसे कह सकते हैं कि उसका टोटल एनर्जी होगा. अब अपन लोग तो जिसे कह सकते हैं जानते हैं कि ये एनर्जी मिलेगी नेगेटिव में. अगर ये टोटल एनर्जी इतना हो अपन लोग जाने तो वापस इसको फ्री करना तो कितनी एनर्जी देनी पड़ेगी? ऑब्वियसली सेम एनर्जी प्लस 13.58 इलेक्ट्रॉन वोल्ट. सो व्हाटएवर द वर्क डन रिक्वायर्ड इन प्रीवियस केस, द सेम वर्क डन रिक्वायर्ड इन केस नंबर C also. So this is very IMP numerical. Number A, B, C. In part A, simply we have to find energy, but zero potential energy we have to consider at infinite separation. तो अपने को अब जिसे कह सकते हैं कि, यानी मैं अब सिंपल लैंग्वेज में बताऊं कि दोनों चार्ज पार्टिकल है उसको इनिशियली इनफाइनाइट पे रखा हो, वहां से अगर दोनों को 0.53 एंगस्ट्रॉम की दूरी पे लाया जाए तो कितना वर्क डन करना पड़े, पहले वो फाइंड किया हमने. वो वर्क डन मतलब एनर्जी जो आया था minus 27.60. फिर बी पार्ट अपन लोग जानते हैं वर्क डन फाइंड करने का था तो टोटल एनर्जी फाइंड की और वो नेगेटिव तो उतना पॉजिटिव दे दिया. सी पार्ट में वापस लोगों को कंफ्यूज होता है तो ये पार्ट को याद करो. ए में इनफाइनाइट था रेफरेंस. अब ये लोग बोल रहे हैं कि अगर दोनों चार्ज पार्टिकल 1.06 एंगस्ट्रॉम सेपरेशन पे हो और वहां से दोनों को 0.53 एंगस्ट्रॉम सेपरेशन पे लाया जाए तो कितना वर्क डन करना पड़े. तो ऑब्वियसली हमने UF माइनस UI लिया. UF का मतलब है पोटेंशियल एनर्जी एट 0.53 एंगस्ट्रॉम एंड UI दैट मींस पोटेंशियल एनर्जी एट 1.06 एंगस्ट्रॉम. वापस देखो पार्ट ए में फाइनल स्टेट तो वही है 0.53 एंगस्ट्रॉम सेपरेशन वाला, मगर पार्ट ए में इनिशियल स्टेट में दोनों एक दूसरे से इनफाइनाइट दूरी पे थे. दोनों एक दूसरे से इनफाइनाइट दूरी पे थे मतलब अपन लोग फॉर्मूला अप्लाई करें K Q1 Q2 by R और R इनफाइनाइट लो तो आंसर क्या आएगा 0. इसलिए हमने प्रीवियस केस में पार्ट ए में UI 0 लिया, मगर पार्ट सी में हमें ऐसा बोला गया है कि इनिशियली दोनों अगर 1.06 एंगस्ट्रॉम सेपरेशन पे हो और अब 0.53 एंगस्ट्रॉम पे लाया जाए तो कितना, यानी कि कहानी देखो पहले दोनों 1.06 एंगस्ट्रॉम अगर वहां से 0.53 एंगस्ट्रॉम पे लाया जाए प्रोटॉन और इलेक्ट्रॉन तो कितना वर्क डन करना पड़े. दोनों इतनी दूरी पे थे बराबर, जीरो पोटेंशियल एनर्जी के लिए दूरी इतनी थी, अब इतनी दूरी पे लाया जाए तो कितना वर्क डन करना पड़े. तो हमें ये पोटेंशियल एनर्जी तो जानते हैं फाइनल, इनिशियली ये दोनों इतनी दूरी पे थे तब की पोटेंशियल एनर्जी हमने फाइंड की, बाकी का पॉइंट आप जानते हो. सो ऑलरेडी वी हैव डिस्कस वेरी इंपॉर्टेंट 2.18. नाउ वी डिस्कस वन मोर बेस्ड ऑन दिस पोटेंशियल and then we can say electrical potential, potential energy, almost 90 points we can say that completed or we'll cover, and so we have covered, and then we'll move towards the next topic. So now within 1 or 2 lectures we'll start the most time I can say heart of this chapter, and it is capacitor and capacitance. But before moving towards the next point I will solve one more that means before moving capacitor and capacitance. So अब दोस्तों ये जो है क्वेश्चन बहुत इजी, ऐसे क्वेश्चन से वो आइडिया पेपर के लिए पूछ सकते हैं और खास करके एमसीक्यूज के लिए. So just concentration required. Now we have to think about quadrupole. What do you mean by quadrupole? You know that monopole, one charge, dipole, two charges. Now quadrupole, four charges. So in this diagram, quadrupole is already shown here. You can see. This is called quadrupole. That means a system of four charges. यानी दो डाइपोल को कंबाइन किया. This is plus q, minus q, minus q, plus q. This is called simply quadrupolar. That means system of four charges. अपन लोग सबका आंसर जानते. That means what is the formula of potential due to a single charge? It is kq by r. What is the potential due to dipole? It is, you can see that kp cos theta by r square. याद करो. तो अब अपने को इसका आंसर फाइंड करना है. Don't forget. And so this is, you can see that distance given already here. A distance or a distance given. Okay. So अपन लोग एक और पॉइंट ये भी क्वेश्चन जिसे कह सकते हैं कि आपके टेक्स्ट बुक रिलेटेड है. सो नो प्रॉब्लम. Just a minute now. It is your, we can say that unsolved number 2.22. Just check it. 2.22. Unsolved number 2.22. So you can take reference. Ready? So figure already given. Your target to find potential at a distance r from this center on axial line. This is called axial line. तो ये लाइन के ऊपर सेंटर से r जितनी दूरी पे, सो r जितनी दूरी पे सपोज कोई पॉइंट P है, यहाँ पे मुझे पोटेंशियल फाइंड करना है. At this point P, we would like to find potential V. Okay, very easy numerical, but we have to compare this answer with these 2 points. So that's why now be alert. What is the meaning of quadrupole? You know that very well. Quadrupole, that means a system of four charges. Now we would like to find potential here at point P, situated distance r. But the basic point, first of all, write potential at point P. It is already V, total potential. I can write total potential at point P. It is supposed to be here. But here mainly electric potential is produced by these four charges or not. This is combinedly, we can say that minus 2q. So already three charges. So I can write V1 plus V2 plus V3. Okay, start. What do you mean by V1? V1, that means potential at point P because of this plus q charge. So what is the formula of potential due to charge? kq by r. What is the distance of point P from this plus q charge? The total distance calculate कर दो, r plus a. So r plus a. Then V2, potential at this point P because of minus 2q charge. It is already at a distance r, but minus, so directly we can write 2kq upon r. K charge लेना है 2q, and then V3. What is the potential at point P because of this plus q charge? What is this distance? Obviously total distance r, a, so r minus a, reference point a. So it is k q upon r minus a. Ready? So now from this equation it is clear that kq common. So remaining portion 1 upon r plus a minus 2 by r plus 1 upon r minus a. Ready? Very easy process, simple mathematics. If you think about LCM, so r plus a, r minus a. Here we have to multiply by r in r minus a. Here minus 2 r plus a. That means r square minus a square. पता चला इधर r plus a और r minus a plus here r minus a already present, so 1 multiply by r and r plus a. Bracket is completed. So v is equal to kq. Here you can see that r square minus ar minus 2r square minus minus plus 2a square. Here plus r square plus ra. Ready? Upon, be alert. Here r cube. ये क्या करो देखो, r common from here and r common from here. So r and r. You know that now new movie. triple R. So R cube. So now 1 plus A by R, and here 1 minus A by R. You know that if you take R common, then here A by R and A minus R. So now R square plus R square 2R square, R square plus R square 2R square, minus 2R square cancel, AR minus and AR plus cancel. So only one term is remaining, 2A square. So V is equal to KQ into 2A square upon 2A square upon R cube, and this equation can be written 1 plus A by R, 1 minus A by R. So 1 minus A square by R square. You know that A plus B, A minus B, A square minus B square. But here they mention if R is double greater than A, already given in data, just check it. So R is double greater than A, already R square in denominator. What about with this term? So A square by R square is neglected or simply 0. So what is the potential? I will write directly here. V is equal to, or you can also write here, V is equal to KQ 2A square upon R cube. This term is neglected, that's why. So this is your, we can say that formula of potential on axial line of, you can see that quadrupolar, most IMP. But we have to compare this answer. Okay, from this equation it is clear that potential due to quadrupole is simply inversely proportional to the cube of distance. But for monopole, we know that potential due to monopole is inversely proportional to R because of the formula KQ by R. And for dipole, you know that potential due to dipole is inversely proportional to R square. Formula जानते हो, Kp cos theta upon R square. But for quadrupole it is inversely proportional to R cube. तो बस ये कंपैरिजन ही करना है. और ये जो तीन पॉइंट्स आप दिख रहे हो, क्वाड्रुपोल, डाइपोल, मोनोपोल, ये MCQs के लिए मोस्ट IMP. So just concentration required. You can see that in very easy, simple mathematics, 3 formulae, and common formula I can say the potential due to charge. So friends, this is your answer number 2.22. No doubt IMP for numerical section of board. तो ये सब क्वेश्चंस हमने डिस्कस किए. अब जो हमारा नेक्स्ट लेक्चर है उसमें ज़्यादातर हमने पोटेंशियल सब कुछ डिस्कस किया. अब नया सेशन शुरू करने से पहले प्रैक्टिस सेशन रखेंगे. उसमें पहले IMP फॉर्मूले रिवाइज करेंगे और फिर एप्लीकेशन. सो जेडबल यूनिट सेशन में जाएंगे नेक्स्ट पॉइंट में कुछ शॉर्टकट्स थ्रू. सो रिवाइज ऑल लेक्चर्स. अब यहाँ तक के जो लेक्चर्स 11B तक इतने सारे लेक्चर्स आपके पास है. मैं कहता हूँ आने वाले वीक तक सब कुछ रिवाइज कर दो, बेस्ट ऑफ द बेस्ट, क्योंकि नेक्स्ट लेक्चर विल कंसीडर सम मेगा टेस्ट, जेडबल यूनिट प्लस थियोरेटिकल न्यूमेरिकल. सो बी अलर्ट and you know that very well. Use each and every moment. Use each and every moment. You can see that at your home. Be safe. Thanks friends.